Okay, question 9. So we're looking at angles in parallel lines. We've got the parallel lines here. So what kind of angles are important? Well, you probably remember things like the Z shape running between your parallel lines. Now that doesn't get you any marks saying Z shape, does it? So we think of A to Z map, or try and make a link between A and Z to remind you that they are called alternate angles. If you can find a Z, alternate angles are equal. So you can use that as one of your reasons. Okay, so if we look for a Z in our parallel line, so travelling down the parallel line, then we can hop to the other parallel line down here, and that makes a Z. So we know the angles that are enclosed there are equal. So this one is 65 degrees. And then I'm thinking about, well, there's a triangle here with some markings on it. These lines are important. They're telling me that the lengths of those sides, FG and BG, are equal. So BG equals FG. Probably already told us that this is the case. GB and GF are equal. Okay, so that means that we've got a triangle with two sides the same. So we've got an isosceles triangle, and base angles in an isosceles triangle are equal. Okay, so this is another good rule that we can use, because we're asked to give reasons about why our x value is what it is. So we're already sort of discovering the reasons that we need to state if we use them. So base angles, I've turned the triangle up so that the base angles are on the bottom, but the base angles in the diagram are here and here. So it's these two angles, not these two. Alright, follow where the lines come from. So this is one side that's the same, this is the other, and it's the angles at the bottom of those sides. Okay, so you always have to imagine that you turn the triangle up this way, and it's those angles down here at the bottom of the sides that are the same. So that's 65 up here. And there's a couple of ways to get x really. We can work out the missing angle in the triangle if you want to. It gives you another reason that you can use. So you know that triangles, where can I write this? So the angles, very important to say, angles in a triangle add up to 180. Okay? Add up to 180 degrees. And that's another reason. 65 and 65, that makes 130, leaves us with 50. And that all adds up to 180. And then you can use another rule. There's plenty of rules to choose from. This rule here, angles on a straight line. Angles on a straight line. Oops. Add up to, sorry, my handwriting is terrible. Add up to 180 degrees also. So x would be 180 minus 50, which is 130. Didn't think it was going to let me write that in there. So it says work out sides there, give reasons for your answer basically. So also, I mean, labelling the diagram is good. You can do that, but make sure that you're also, you know, when I did 180 minus 50 equals 130, I have not shown all my calculations, so I would write down everything you type into the calculator as well to show how you got these numbers, and then pick some of the reasons that you used along the way. Okay, I'll always give look at the marks, so and then think about how many reasons you need to give. I would always give at least 2 reasons if it's a 4-mark question. Okay, hopefully that's useful, guys.